Okay, today we're going to go over the 1-3 notes, which is subtracting integers. So we're going to put together what you did in the activity, come up with a rule, and use the rule to complete the subtraction problems now instead of number lines. So our rule: to subtract an integer, make sure you're writing everything that I'm writing, add its opposite. So I like to think of it as same, change, change. And I will write that down below after we're done with this one. So if I had 3 minus 4, I'm saying that that's the same as 3 plus a negative 4. So if I have to subtract, it's the same as changing. So the first number stays the same, changing the subtract to plus and changing the second number to its opposite. And then we would do the addition problem. So if I was doing a number line and I'm subtracting, the first number is 3, so you see they go out to 3, and taking away 4 means you go left and you end up at negative 1. If you're doing 3 plus negative 4, you'll see that starting at 0, you go 3, while a negative 4 goes left just like a minus 4 does, and you both end up at the same answer. So the first number stayed the same, right? Same. The minus changed to plus, so I call that a change. And the positive 4 turned into negative 4, so that's my other change. Okay? So I like to call it a same, change, change. Some people say keep, change, change, means the same thing. So for subtracting, we add its opposite. Okay? Keep, change, change, or same, change, change. Then you follow the addition rules. So remember the addition rules: if I have same signs, I'm going to add, and I'm going to keep the same sign. If I have different signs on addition, I'm going to subtract and use the sign of larger amount. And when I say larger amount, I mean, do I have more positives or do I have more negatives? If I have more positives, then that's the sign, because there's going to be, if I was using 0 pairs, there would be positives left over. If I have more negatives, there would be negatives left over. So that's the final answer. Okay, so we're going to change these. We're going to rewrite them so they're an addition problem first. And then we're going to follow our addition rules. So I do this anytime I have subtraction with a negative, or I'm doing a small number minus a big number. So the first number stays the same, subtract turns to plus, and the positive 12 now becomes negative 12. Okay, I go back up here and I have different signs now. I'm going to subtract 3 and 12, right? So I would have, in my head, I'm going to make like a little thought bubble. In my head, I'm doing 12 minus 3 and saying that's 9, right? So that's 9. Do I have more positives or more negatives? I have more negatives, so my answer is negative. I'm going to rewrite B. Same number, negative 8, subtract turns to plus, negative 13 now becomes its opposite. I got to change that to its opposite. So this is my thought bubble, because this is what I'm doing in my head. You wouldn't have to actually write this part out, but in our notes we can't remember what we were thinking unless we write it down. So I've got 13 minus 8. You're just going to subtract the two numbers, ignore the signs and subtract the two numbers, and I get 5. That's when you go back up here and say, what do I have more of? I have more positives, so the answer is positive 5. Let's try some more. Now on number 1, do you see how it's just 8 minus 3? We don't have to change it. If we did change it, we'd get the same answer, right? We'd have 8 plus negative 3. We would subtract them and we have more positives. But if you have a big number minus a small number, you don't need to change anything. You've been doing that since 2nd grade, so you don't have to change that one. Number 2, though, we want to change because the small number is first. So we're going to keep the first number. We're going to change the sign to a plus. We're going to change the second number to its opposite. So keep, change, change. Now I've got different signs. So in my head, this is notes. We wouldn't do this on our regular paper unless you really want to. We're going to think in our head that we're subtracting 17 and 9. So if I do 17 minus 9, I get 8. So I'm going to put 8. Then I have to decide, do I have more negatives or more positives? Because if I had chips and I'd be crossing some out, there would be negatives left over, right? So it's negative. Number 3, same or keep, change from subtract to plus, change from positive 3 to negative 3. So take your time in doing that, okay? Try this out on your own. Pause it if you have to, and then check the answer. Okay, so I now have same signs. When I have same signs, I think of same and sum, right? I add. So negative 3 and negative 3, 3 and 3 is 6, and I keep the same sign. Because remember, you've got 3 negatives and 3 negatives, and you can put them in a pile, and they're the same thing, and so you're just adding the negatives together. Number 4, I've got negative 14, change to a plus, change to a negative. So keep, change, change. And I got same signs again. When you have same signs, you remember, think about this in your head. I've got 14 red chips, 9 red chips. All together, I'm going to have 23 red chips, right? They're still negative. So we add them and keep the same sign. Number 5, I like the ones like this. You keep, you change to plus, you change to a positive 8. I like those because 9 plus 8 is easy for me to do. I don't even have to think about any negative rules. It's just 17. Number 6, negative 12, I keep, I change to plus, and I change to the opposite, 12. I actually did not need that parenthesis. I don't know why I wrote it. I've got different signs, but what I notice is that they're opposites. And when I add opposites together, I always get 0. Not when I subtract opposites, when I add opposites. Because number 3 up here had a subtracting opposites. You got to be careful. Some people put 0 there. You got to turn it into a plus first. Keep, change, change before you can see if it's opposites or not. Number 7 and number 8 have 3 problems. So we're going to evaluate them. We have to do the order of operations. If there's more than one operation, we have to go from left to right. Now, because this is a subtraction, we can't just change the order, go whatever order we want. We have to go left to right. So the first thing I'm going to do is just this problem and do the keep, change, change. So I'm going to change to plus, I'm going to change to positive 12, and I'm going to rewrite the minus 14. I'm going to solve the addition part. Different signs means I have to find the difference. 12 minus 7 is 5, and I have more positive, so it's positive. Then I got to take away the 14. So now I'm going to keep, change, change again. 14 and 5 are different signs. 14 minus 5 is 9, and I have more negatives, so it's negative 9. Number 8, from left to right, keep, change to plus, change to negative 16. You can still write the minus 8, but we're still working from left to right. So if I add negative 9 plus negative 16, that's all red chips put together. You add them and you keep the same sign. Now you have to finish, keep, change, change. So now I've got negative 25 plus negative 8. Those are same signs, so I want to add those two together. 25 plus 8 is equal to 33, and we would keep the same sign. All right, so an application problem, or real life application, it says which continent has the greater range of elevations. If you're finding range is the difference between two numbers. So that means we have to subtract them. So from the highest to the lowest, you would actually be subtracting them. So if you're subtracting them, it's 6,198 minus negative 86, and this one would be 5,895 minus 155. Well, to solve that, because of the negatives, we would change to plus, we would change to the positive, and it actually gets bigger, because if you're looking at a number line, this is way over in the negatives, this one's way over in the positives, and so the number of spaces is actually bigger than just subtracting two positive numbers. You're actually subtracting a positive from a negative, and it actually gets bigger. Okay?